Students, hope you are attending the classes of sampling techniques. This is the first lecture of this week of sampling technique. I have shared here a few examples of cluster sampling. From a book. This is a table of few states of United States in the form of clusters. First cluster consists on the states WAOR, MT, NVID. Similarly, the second cluster is CA, AZ, NM, AK, and HI. These are the names of the states, and these are the clusters. There are 10 clusters. Now, problem is that select 6 clusters from above table using simple random sampling without replacement sampling. Record the value of real estate farm loans from the selected states. From the population from the above population. The value of the real estate farm loans is given below here. Here is the value of the real estate farms loans from each state. That is, the real estate farm loans from state WA is equal to 1100.745. Similarly, the values of the real estate farm loans from other states is given in this table. Now come on the question, statement of the question. Estimate the average real estate farm loans in the United States using cluster sampling. Estimate the variance of the estimator used for estimating the average real estate farm loans. Construct 95% confidence interval. Now the sample has been selected of 5 clusters. First cluster, third cluster, fourth, fifth, sixth and seventh clusters out of 10 clusters. The respective values are given in this table, taking the sum of the observations from each cluster, that is yi dot. These are the value yi j. J is the number of observations in ith cluster which has been summed here. This is the sum of the observations 1100.745 plus 114.899 and so on plus 53.753. Similarly, we have taken the sum of all clusters of the values of real estate farm loans. There are M clusters. M is equal to 5, N is equal to there are 6 clusters. There are 6 clusters which has been selected, and each cluster consists on 5 states. M is equal to 5. Thus an estimate of the average real estate farms loan in a state is calculated here. Y double bar is equal to 1 over n into capital N. Sum of I varies from 1 to n. J varies from 1 to m. This is the sum of the all observations, which has also given in the above table, that one, divided by 6 into 5. 6 is the sample size, that is 6 clusters, and each cluster consists on 5 observations, 5 states. So it has become 767.2656. You yourself have also calculated these values and check the accuracy of this answer. Now to find the variance of this estimate, variance of a sampling distribution of mean in cluster sampling. First we have to calculate S square B, variability between clusters. Sum of I varies from 1 to n, yi dot bar minus y double bar whole square divided by n minus 1. after taking the deviations from cluster means of each observations and taking squares, we have the observations here, and yi dot bar is the mean of the observations in first cluster and second cluster, third cluster. These are the total divided by 5. It will become 313.64. 313.64 minus the mean of the cluster sampling, that is 767.2653. We have obtained these values. Taking sum of these values divided by n minus 1, 6 minus 1, that is 5. It has become 163,731.828. Thus, an estimate of the variance of a sampling distribution of mean is given by v hat y double bar is equal to 1 over small n divided by 1 over small n minus 1 over capital N S square B is equal to 1091.455. Now the confidence interval of the population mean y double bar is given as y double bar plus minus t alpha by 2, where we have degree of freedom is equal to n into m minus 1 into v hat double bar under root. It has become, that is the 95% confidence interval 511.62, 982.906. You can verify by your calculations of by making the complete calculations of these examples yourself. This is a theorem. Relative efficiency of the cluster sampling with respect to simple random sampling is given as S square divided by M S square B, where S square is the variance in simple random sampling and MSB square, SB square is a variance within clusters, between clusters. Now dividing the variance of y double bar or variance of y bar, we obtain that S square divided by M into S square B. Use the relative efficiency in next example. Suppose the United States has been divided into 10 neighboring clusters, each consists of 5 states. Now we have take the states of in the neighbors of certain states as a single cluster. WA, OR, MT, NV and ID states are close to each other in the neighboring of each other. And now we have given here the value of these 5 states, real estate farm loans of these 5 states. This is the mean of the clusters, and this is the overall mean, taking deviations from mean of the clusters, and overall means taking squares. After taking summations, we have 1653961.00. Y double bar is equal to this. S square B is equal to 183,773.444. And also we have S square. It is the simple variance of these observations. Now relative efficiency S square divided by M into S square B is equal to 0.3722. In this case, the cluster sampling is less efficient than simple random sampling. Thus, there is no gain in efficiency through the cluster sampling in this examples. As we know that if rho is greater than 0, relative efficiency is greater than relative efficiency is 0.3722. And why here the cluster sampling is less efficient than simple random sampling? Please try to understand this example and come on another example. Here we have find the estimates of P, the proportions of the freshmen who own automobiles, and 95% confidence interval for the same. Listen attentively. Suppose we are interested in estimating the proportion of freshmen in a certain university who own automobiles. Suppose the freshman dormitory consists of 10 floors and 50 rooms on each floor, and 2 students live in each room. We take a random sample of 3 floors and obtain the following data. Second floor has been selected, which have number of students having automobiles is 50. Similarly, 7 and 9 floor has been selected as a sample, having number of students, and the number of students having automobiles are 60 and 45 respectively. Now these are the proportions P1, P2, P3 divided by 3. It is the overall proportion of the students having automobiles. As there are 10 floors, therefore 10, 100, therefore P is equal to 0.5, 0.6 and 0.45. Here we have calculate S square P, pooled variance of these proportions. It has become 0.001365. S square, taking under root of this value, SP is equal to 0.037. So 95% confidence interval for P is equal to 0.52 plus minus 0.074. Okay, this is the end of this example. SP square is given here, which we have used here.